Okay, so hi everybody, and welcome to the 22nd Community Sync, Rocket Community Sync. Agenda for today is full with a bit of demos. So first we have Casey, then me, and then we have a couple of status updates and progress updates on the CRI side, so Kubernetes and App Sandbox. And then there are some points up for discussion, and if you have like some more, just keep adding to that, and we will touch into them. So I think that we can just directly start with Casey. So that's up to you.
Hello, everybody. So the thing that we've been working on, as a concept, is running runc inside the systemd nspawn pod, or whatever pod, it actually doesn't matter, instead of using unit files. And so basically the justification for trying this little experiment is systemd unit files may not necessarily have all of the ability, they don't have the ability to tweak everything that our users may expect us to be able to tweak. And so what we're doing now is we're still launching a system. In this branch, we still launch a systemd nspawn pod or a KVM pod, but runc is responsible for actually launching each individual application. So I'm going to, if you look in the agenda, you'll see a link to a sort of small Scratch issue that I have, and in that issue is a link to the code. And I'll just do a quick demo here. Let me figure out how to share my screen. Okay, looks like you're getting the desktop. So let me just, this seems way too big. How do I, is there any way to, okay, I guess I'll just, okay. So. How's this? Is this good, or is this too big? Okay, I gotta go get this up. So the first thing I want to look at just is so runc. The way runc works is that instead of taking command line parameters, it takes a JSON file for the runtime parameter. So I just want to look at a sort of a sample runtime JSON file from runc. You can see it has everything we sort of know and love. It's got it has the process, which has some args. The first arg is, in fact, the binary. It will actually search path. It has the ability to give it capabilities. You can set the R limits. And then you can give it some mounts. Interestingly enough, these mounts are not just bind mounts. They could also be, they could also be, special mounts, so pseudo mounts, or device mounts. We don't yet support device mounts, but I'm working on it. Nor do we support bind mounts, but that shouldn't be long. And then it also supports, the full range of Linux restrictions, things like which namespaces we should be creating for this individual process, devices to create. So this is it's basically by make node, C group type flavored resources, and some mask paths as some examples. So let's see it in action. Oops, making it big. Pay no attention to the man behind the curtain. So I'm going to start a CRI or app sandbox. Nothing too exciting here. Thank you very much. And in another tab. Yep. I will get the pod, and I'm going to do an app add. And the only thing different about this app add is that I'm passing this extra argument, runc spec, and a path. Oops, that's not going to work. So the only difference is I'm passing this runc spec argument right here, which is that runc file we saw. Nothing too exciting, and then but before I do this, I want to just look real quick at the exec. The exec for this is, it's going to do a mount, so list all the mounts, and then it's going to list this device. And then it's going to sleep for a while because, got to sleep. So let's start it. if we go over back to the standard out of the sandbox, you can see that our runC app has listed all the mounts. So it has all the mounts we asked it to create. It has the shim, MQ, sysfs, everything that was in that config file. And it also has the device that I asked it to create. And this is a real application of the pod. So I can do rocket app list pod. And you see Alpine SH is running. I can do rocket stop. And it stops it. Well, it doesn't say anything. So yeah, so that is the first pass at using runC as the runtime engine inside the pod for each individual application. Any questions?
I got one question. Because would it be two levels of isolation in this approach? One from the nspan and another, but I'm not so. Maybe I'm missing something here because I thought that runC also. The role of our runC is like as an isolator. So would we do two levels of isolation here?
Yeah, you're right. We are doing two levels of isolation here. The answer is that for a good chunk of the levels of isolation offered, they nest well. You're totally right that you can create a runC config file that doesn't make any sense. For example, trying to mount a device that isn't in the isolation. This is not necessarily intended to be a full, 100% runC compliant setup for that exact reason, because it is two levels of isolation. But it does make sense, in some reason, it's really just nice to have an nspawn pod, because then you have things like machine-ctl and journalctl and everything. And we can use systemd inside the machine as our process manager, so we don't have to write some sort of complicated process and state and transition manager. But the ability to configure restrictions in runC is way more sophisticated than that in a standard.
I got one question. I don't know, my PC just crashed, so I don't know whether we covered this, but how you are adding the application to run with runC? You do not use systemd unit files anyway?
So actually, ironically, we create not just one, but two systemd unit files. So, basically what we do is we create a systemd unit file. It's very simple. If you look at the diff, you can see that there's like a 5 or 6 line unit file that executes runC. Since runC has a really simple one process per application model. The application exists. Now runC, because we don't want runC to be screwing around with the C groups too much inside the pod. runC actually has a mode in it where it will talk to systemd via dbus and create a transient unit and use systemd's C group engine wherever possible. So ironically, we're using runC to talk to systemd again. That may change, but this is how it's working right now. But yes, it is a standard unit file as far as lifetime is concerned.
Yes. What was the main motivation about this POC? Just because runC is, let's say, I don't know, it's OCI, right? OCI compliant. And I think what I saw that the systemd actually got more functionalities to provide isolation than runC.
So just to give a bit of context here, what we are trying to do is an experiment with runC. The idea is trying to move some of the properties that we are currently setting on the systemd service unit for every single application, and moving them into runtime spec configuration. And so we are moving some responsibility from systemd to runC, just because at the current moment, the runC runtime specs allows for more flexibility than what we can configure directly with systemd. So And also answering the previous question, if we have like two nested level of isolation, this is more or less the same as the split between what is the pod scope and what is the application scope. So we have a first level of isolation for the pod, and then you can add additional configuration for every single application. So this runtime specification, this runtime spec manifest will take care of a lot of other things, not only isolation, like setting up, like specifying which user and group and supplementary groups, and if some path has to be masked or not, and if you want to have like a dedicated cgroup namespace for every single application or something else. So that's what the RunC at the stage 2 level will provide us, which is kind of orthogonal, let's say, to what we currently do at the stage 1 pod level.
Yes.
Was that clear?
Yes, sure. Thanks.
Yeah, this is RunC does not have anything to say about image formats. You know, you hand it a root file, an already rendered root file system. So this isn't introducing any sort of new image format. This is just the execution engine.
Okay. And any other question on that? Okay, I guess not. So we'll continue. I have a demo from my side. What I was working on in the last few days, few weeks, is support for attaching to streams and to TTY of whatever application that you want to target in a pod. So this is basically like generic attaching support to existing running application. It is mostly done, let's say, or at least I have a good part of the implementation for that, and also a working demo. So that's what is gonna start right now. If I manage to share my screen. Cool. Yep. Where is my timer? Okay, yeah. So are you seeing it? Yes, fine. Okay, so this is already also based on top of the application sandbox and CRI works that we are doing. So I'm gonna demo it in a mutable pod environment. The first things that we do, again, it's starting an application sandbox, so an empty one, this time with systemd run. This application, this sandbox is now running, and it is completely empty. What we do is wait, let me first record this UUID. What we start doing is adding an application, like a Debian image, for example. The only interesting option here are that you can specify what we want to do with the streams, so standard in, standard out, and standard error. In this case, for example, I'm running with an attachable standard in and standard out, but without any standard error. So I just add this application, and then I will start it. So this is now running. And the part of the novelty of this demo is that there is a new command at the moment, which is not this one, but wait, this one. Come on. So there is a new rocket attach subcommand that will let you attach to a running application inside the pod, and you can specify what do you want to attach. So for example, if you want to attach in read-only mode, you will specify only the standard out. Otherwise, you can specify like all the streams that you want to attach. If we do this, we should be now running inside these applications. So we will have, for example, the host name. We can do some other things like looking around it. And as I mentioned before, here we only have the standard out. So if we do something like a echo hello world, we will see it here. But if we do it the same things to the standard error, we will not see anything because we don't have any standard error. This is one mode, and what is peculiar about this mode is that we don't have any TTY attached here, so any command that requires a TTY for colors or any other control channel will not work. And this is why there is another mode. So let's start another application here. This time it's a Fedora image, application 2. And the difference is that here we specify that we want to attach standard in, standard out, and standard there to a TTY. So we add this application in the pod. Now this pod will be running with, with two applications inside of it. One is running, the other is not. We just start it. That's now running, and you can actually attach to that. So this time it's application 2, and we want to attach as a mode to the TTY. Now we are inside that, and as you can see, this time we have like full colors and full TTY support. So we are now running with a real TTY. That's basically all the demo part. For a bit of context, this will unlock some other feature. For example, that's what Kubernetes will use for doing kubectl attach and kubectl exec. And these TTY and no TTY mode and read-only mode are all supported directly in Kubernetes, so that's also needed there. It is mostly done. I have it in a branch in GitHub, but not yet in a PR that will follow soon, because it depends on merging first these applications app sandbox support. And there are still some details missing. As you can see, I'm not doing any echo controlling on the TTY, so you are getting 2 times echo what I wrote here and what the terminal actually is echoing me. So the application terminal is echoing me. And these are small details that still need to be fixed before finalizing it. And I guess that this is all from my side, and I can stop sharing my screen. Fine. And I'm happy to answer any question or doubts that we have around that.
It works in KVM, right?
Yes, it should work on KVM. So at the moment, it works in a way that it is listening in some local port inside the pod. Another interesting thing is that all the resources used by this kind of attaching mode are already accounted for every single application, and there are no coupling between different pods and different applications, so there is no central daemon here. And the other thing is that it just reused the normal enter exec Rocket stage 1 semantics, so you can just swap for another stage 1 and it will work. And I was actually looking into some more interesting stuff, like they recently introduced it in kernel, the VSOC family, that will probably allow us to use a bit less resources for doing all of this, but that's probably some experiment for the future. I didn't test with KVM, but as I designed it, it should already work in that sense. Okay, I guess that was it. So it was like a good session of demos. Let's move forward. So we're gonna give like a small progress update on our sides. It has been mostly a week where we experimented with a couple of stuff, and we were trying to finalize this TTY and other works that we have in progress. The biggest one probably at the moment is all these changes related to CRI and App Sandbox. There is currently a pull request open against master. The link is in the agenda, and we are planning to have it in a good state, which can land soon in master. So we are targeting at having experimental support for that in 1.19. So if I'm not wrong, in 1 week. This is currently a what we call a gated or experimental feature, in the sense that it's will be available in the official release, in master, and in the next release, but it will be gated behind some debug or experimental environment flag. Just because we are not completely sure at the moment about the UX part, so the command line interface and everything else, and we still want to properly document and test that part. So if you have any comments for that, that's the good time to leave them. I already did a review pass, and that's going to be, my comments will be addressed soon. And I think we don't have any other interesting updates on that side, because I think that Casey was on the RunC, and Sergiusz was again working on systemd.
Yes, exactly. So I'm working on the systemd read-write support for privileged containers. I have one bug left, which I'm literally debugging while watching and taking part in this sync. So this will hopefully land in systemd and spawn master soon too. And then I have stuff in Kubernetes upstream, but this does not fit into this sync. Yeah, that's all from my side.
Okay, fine, thanks. I think we can go to the next point, which is anyway related to what you guys are doing in the KVM side. So maybe if you want to give a short status update or what you are working on. I saw that we have a couple of topics open at the moment regarding the KVM stuff. One is this big CNI reworking. I think that Casey was having a first review at that. I just want to know, like, what are your plans, or what is the timeline, and what do you plan to have in that topic? And the other one, but maybe we can discuss this one first and then we move on. So I guess that Lukasz was the one behind that.
Yeah, sure. Actually, the main heavy lifting for QEMU is done, but we were talking internally that KVM would be deprecated pretty much soon. LKVM, sorry. LKVM will be deprecated soon in the favor of clear containers, more approach with QEMUlite and etc. So we're talking about it brings little to no sense to create custom patches for LKVM, which it's very unlikely to be mainstreamed. You know, it's lots of effort put into nothing actually. So this work is blocked on the making QEMU default hypervisor for KVM playbook. And pretty
Okay.
much I've got some other tasks not related to Rocket, but the only thing left here it's block on making QEMU default hypervisor.
What about networking?
Very simple cleanup of the code in networking KVM Go, but it's just the addition of 1K lines, something like that.
Okay,
But,
so just go ahead.
but what about your pull request? That is work in progress? It's closed already?
No, it's
That's
not.
another solution from QEMU networking, I heard. And I saw it.
Actually, it's not yet. It's not yet merged because of the fact that it will be needed to write custom processing flags for the LKVM. And we talk about it that it brings little to no sense at this stage.
Okay, so the idea at the moment is that we first focus on promoting the QEMUlite clear container as a main option instead of LKVM. We deprecate LKVM, and then that will be the solution for the networking.
Yes, exactly.
Okay, so there is no need for us to start reviewing that PR at the moment, apart from what Casey already did before, right?
Yes.
Okay, fine.
One thing I did notice, it's really cool. I really like it. I didn't give it like a really intense review. It definitely needs that. I know I personally have changed all of that networking code, so you're going to have the merge from hell. So I would recommend tackling that sooner rather than later.
Okay.
And let me know if you need help with it, because it's not too bad, but I know that you're going to get some merge conflict.
Right.
Yes, but as far as I know, the networking changes are mostly working for QEMU. It's just they are just made to work only with QEMU. So we just need to treat LKVM as deprecated, but the changing the default hypervisor in angle of QEMU and QEMU Lite is a different thing, I think, which is actually a different topic.
Okay. Okay, fine. And the second question that I had related to QEMU and LKVM, it's like we should come up with a process, or at least like decide when to update and who should take care of deciding which version is the usable one. At the moment, we have not super old but not too recent kernel in the guest. And also for QEMU, I've seen that there is like a new release of that, and we were also talking about probably switching to QEMU Lite, or let's see how much time it was taking to upstream everything else.
Yes.
So I think just
about the kernel, I was asking on some issue on GitHub whether any one of you had some doubts about bumping just kernel simply, and I can't imagine any problems with this, so I think that we can just bump the kernel. About QEMU Lite, I get another topic. What about the stage 1 image in official release on QEMU?
Sorry, I didn't hear it. Again, sorry.
Okay. About the stage 1 image with QEMU in official release, I saw there was a hard discussion in this. Luca were some, I don't know, got some doubts about this, but the final comments actually covers all these doubts. So I don't know.
On that side, I think that we just have to decide, like, if we want to use QEMU, if it is fixing all the LKVM bugs that we had before, or if we want to switch directly to QEMU Lite, because anyway, in the long term, we basically need it.
Do we really need to switch default hypervisor before providing the stage 1 images in official release?
My idea was that I would prefer not to like build and ship all of them, but it depends. Like we can come to an agreement and discuss what we really need to do. I think it's a bit confusing for users to have like 4 different stage 1 and 2 just for the KVM. And in general, I would like to have a plan already if we start. It's okay for me starting introducing another image, it's just that I would like to know when we can drop the other one and what are the blocks.
Yes.
Because at this point I thought that the other one is mostly deprecated, so I'm actually happy to push a bit forward in the other direction. It's just that I don't have a clear vision about what is the status and how many things we are still broken even with QEMU. That's...
Actually, we don't know right now for how long we will work on Racket anymore. I don't know, maybe we will change some priorities inside our company, but right now at least one part of my hand is still looking on the Racket stuff. So I think I should just make some plans to do before maybe just dropping the Racket from our side. So the thing is, for me, maybe this image, the stage 1 image, and maybe the clear containers QEMU Lite provided. You listed the issues that we got. It's the devices problem and also the networking problem. So I think we will just solve both of these issues, and this would be our last thing.
Okay, so this is also a bit related to the other discussion, which was how we should schedule for updates to kernel, QEMU, and everything else. I guess that the answer is basically that we will take care of it, and we will just try not to break tests and basically not introduce regression when bumping versions.
Yes,
that's correct. Okay.
Yes.
Okay. Fine. Anything else on that topic?
No, I believe that's all.
Okay, so thank you. I saw that Iwan was adding another discussion point. Can you just say what's that?
just beating the drum of programmatic interaction again. I think I've talked about this one before, but to me, it still feels like an open question how best for users to interact with Rocket programmatically. And we've talked at various times about calling the binary, which you of course have to for running things, but not necessarily for everything else, versus calling libraries. And for calling the binary itself, we have output JSON flags for some commands, but not others. And we don't have a way to input any programmatic form other than flags, which are not sufficient for a few little bits here and there. I just wanted to know if we had a way to get that discussion rolling forwards a little further, or if we had opinions we wanted to talk about there.
What is your opinion on that, just for a start?
I think that output JSON globally and being able to either split up some input flags so that they're all representable or have a input JSON are great starts. I do think that the library thing is what we want eventually for most parts of it, with the exception of actually running things. So I feel that that is the correct path. I do think that output should be global and supported by basically everything, with, again, very few exceptions, probably just run.
Mm-hmm. Yeah, I think that more or less I agree on that. I don't know, like, with which priority to assign of every one of those. I honestly think that it's in the long term, it's a good way to be like to implement a proper library and expose interfaces that are consumable by other applications and other programs. The problem with JSON is that we started doing that. So JSON as the output, we started doing that, but we don't have a clear uniform framework for outputting stuff. So it's probably for the moment, it's being more like we are trying to convert every single subcommands to output JSON. And it's progressing more, but quite slowly. So maybe we can push a bit more in that direction as an initial change, let's say. And for the input part, I'm not completely sure what we should do. I think that for the CLI, it's mostly fine to accept just plain commands and come up with some kind of custom format. But I see that there is some value in just passing a manifest. So something similar to what Casey was showing before for the runtime spec. I think there is some value in that. I was honestly trying to propose or to come up with a proposal that we either take single parameter and we convert internally to a manifest, like the runtime manifest, or you pass a manifest for the application, similarly to what we do for the pod, but for a single application. And then basically it's up to the user to decide either if he wants to pass every single option on the command line, or if it is using some kind of pre-generated manifest that we are not touching anymore. So that's basically in line with what we do for the pod and the pod manifest at the moment. That was my opinion on that. I don't know if it makes sense or if there are better options.
I think that option makes a lot of sense, though I also think that just calling it as a library makes slightly more sense as a end goal, though that one probably will take much longer.
Yeah, I guess so. We started in this CLI branch to split out a bit of bits and pieces that can form a proper library, but it's definitely experimental, let's say, at this point, or something that we just started looking at. So I don't expect to be very user-friendly for the first times. So that's it. Anything else in that topic or any other opinion? Okay, I was checking the agenda. I think we don't have anything else to discuss here. So I'm just leaving a couple of seconds of blanks if anybody has something to say. Otherwise, let's just say thanks to everybody for joining and see you next time. Bye.
Bye.